Laws of logarithms. There are various laws of logarithms and, unsurprisingly, they are all derived from properties of indices with which we are all familiar. That's because, as we've seen, a logarithm is just another way of looking at an index. Note, in all the expressions below, a, x, y, m, and n are all greater than 0, and a is not equal to 1. The first law says log to the base a of m times n is equal to log to the base a of m plus log to the base a of n. As an example, if we had log 2 plus log 3, that is equivalent to log 6. And just like index laws, sometimes it's useful to go this way, and sometimes it's useful to go this way. This first one I'm going to derive in full, and the others I will just state. So to derive this, let x be equal to log to the base a of m, and y be log to the base a of n. Using the equivalence of log and index statements, the x equals log to the base a of m can be written as m is equal to a to the x, just changed to exponential or index form. And in the same way, n is equal to a to the y, coming from here. So m times n is a to the x plus a to the y. And we can just use our index laws on that. So therefore, mn is a to the x plus y. Remember the multiplication index law where we add the indices. Using the equivalence of log and index statements in the other direction, log to the base a of mn would be x plus y. So we have mn is a to the x plus y. Writing that into log form gives us log to the base a of mn is equal to x plus y. This is what we've been using in many of the examples before. But from above, x is log to the base a of m, y is log to the base a of n. So we get that log to the base a of mn is log to the base a of m plus log to the base a of n. And that's law 1. Now law 2 says log to the base a of m divided by n is log to the base a of m take away log to the base a of n. This one is easily derived from law 1 by using the same approach and the fact that n to the negative 1 is 1 over n. And there's other ways of doing that law as well. Law 3, this is sometimes a very useful one. Log to the base a of m to the k is k log to the base a of n. I've mentioned this one before. So if we have log 10 to the power 5, that is 5 log 10. It's very useful in a lot of different contexts. This law is just law 1 applied repeatedly with m equal to n. Log to the base a of m times m would be log to the base a of m plus log to the base a of m, which can be written as 2 log to the base a of m, and of course m times m is m squared. And just repeat the argument for m cubed, m4, etc. When you know about proof by induction, you can use induction, at least for positive powers, to prove that one's true. Log 4 is log to the base a of a is 1. I've mentioned this one before. This one is obvious if we convert to index form. A to the power 1 is equal to a. And law 5 is log to the base a of 1 is 0. This one is also obvious when converted to index form. A to the power 0 is equal to 1. So I say they're obvious, but they're basically obvious if we know our index laws.